Dear students, welcome to mathematics online classes. We will continue with the problems of exercise 10.3 in this class. Here I have written problem number 12 of the exercise 10.3. It is saying if vector A dot product with vector A is equal to 0 and vector A dot product with vector B is equal to 0, then what can be concluded about vector B? Means what we can say about vector B if these two conditions are satisfied. Okay, now let us check the first condition given here. It is given that vector A dot product with vector A is equal to 0. What is A dot A? We know A dot A is equal to magnitude of vector A square. This is 0. Magnitude of vector A is equal to 0 means magnitude of vector A is 0. That means what? Magnitude of vector A is 0 only when A is a null vector. For any other vectors it can't be, its magnitude can't be 0. Here magnitude 0 in the sense it has to be a null vector only. See what we are getting. Vector A is equal to null vector we are getting with the first condition, and second condition A dot B will be always 0 as A is a null vector. Then what can be concluded about vector B? Vector B can be any vector, whether it can be null vector or any other vector it is, product will be 0 only, dot product will be 0. So what we will write about the vector B? Vector A is equal to null vector, therefore vector A dot product with vector B is equal to 0 always. It is 0 always. This implies vector B can be any vector. Vector B can be any vector. These two conditions will be satisfied. This is about problem number 12. Now we will take the next problem, that is problem number 13. If vector A, vector B, vector C are unit vectors, if vector A, vector B, vector C are unit vectors such that vector A plus vector B plus vector C is equal to null vector, then find the value of vector A dot B plus vector B dot C plus vector C dot A. This one we need to find here. Okay. Now let us solve this problem. It is given that A, B, C are unit vectors. Unit vectors means what? Its magnitude is 1 unit. So here we write it is given magnitude of vector A is equal to 1, or else let me write it all together. Magnitude of vector A is equal to magnitude of vector B is equal to magnitude of vector C is equal to 1, and also they have given you vector A plus vector B plus vector C is equal to null vector. Then they are asking you A dot B plus B dot C plus C dot A. Very simple it is. Let me take vector A plus vector B plus vector C whole square. I will take A plus B plus whole square. We know that magnitude of vector A square is equal to A dot A. Here also let me take magnitude of vector A plus B plus C only, no problem. Already it is given A plus B plus C is a null vector, so its magnitude will be 0 only. Magnitude of vector A square is equal to A dot A, like this it is given. So in the same way here it will be vector A plus vector B plus vector C, which will be in a dot product with vector A plus vector B plus vector C, according to this definition. Okay. Now, let me simplify this. This is first of all A dot A dot A. Next, A will take dot product with all three, So, A dot A, next one will be A dot B, then third one will be A dot C. Next, plus of B will take dot product with all three. This will be B dot A plus B dot B plus B dot C. Next, plus of C will take dot product with these three. C dot A plus C dot B plus C dot C. Okay. What is A dot A? A dot A is magnitude of vector A square. Magnitude of vector A square. Next, A dot B, let it be as it is. We want C dot A, A dot B can be written as a C dot A because dot product is a commutative. Okay, write it as C dot A plus of B dot A is there, write it as A dot B. B dot B is what? B dot B is a magnitude of B square plus of, keep this B dot C as it is, C dot A as it is, C dot B is there, you write it as B dot C because dot product is commutative. Next, C dot C is there, this is magnitude of C square we will write. Okay. Let me rewrite once again. Here it is magnitude of vector A plus B plus C whole square. It is given A plus B plus C is equal to null vector, then its magnitude will be 0. Let us put 0 here. Now, and also we know that otherwise we will write one more step. Magnitude of A square. Let me write here also. I want to say one thing. Magnitude of A plus B plus C whole square. Let me write it. Later I will substitute the value. Magnitude of vector A square plus magnitude of vector B square plus magnitude of vector C square plus of A dot B is 2 times. Next, B dot C is also 2 times. C dot A is also 2 times. So, 2 will be common among all those. I will write it as 2 inside the bracket A dot B plus B dot C plus C dot A, like this I will write. See, this can be taken as a formula. 8th standard formula we have studied A plus B plus C whole square is equal to A square plus B square plus C square plus 2AB plus 2BC plus 2CA. If 2 is taken common, 2 inside a bracket AB plus BC plus CA, that is the formula we know. Same thing is happening here also. Magnitude of vector A plus vector B plus vector C square is equal to magnitude of vector A square plus magnitude of vector B square plus magnitude of vector C square plus 2 times A dot B plus B dot C plus C dot A. Let us substitute all the values here. What is this? This is 0, which is equal to, they have given you A, B, C are unit vectors, means magnitude of vector A is 1, similarly 1 plus 2 times this will be A dot B plus B dot C plus C dot A. Okay. Here it is 1, 3 times. This will be plus 3. If I take it to the left hand side, this become minus 3. Minus 3 is equal to 2 times A dot B plus B dot C plus C dot A. 2 will come to the left hand side. This become minus 3 by 2 is equal to A dot B plus B dot C plus C dot A. Okay. Now, what is the value of A dot B plus B dot C plus C dot A? This is minus 3 by 2. This is about problem number 13. Okay, we will take the next problem, problem number 14. Problem number 14 is, if either vector vector A is equal to null vector, vector A is equal to null vector, or vector B is equal to null vector, then A dot B is equal to null vector. Then A dot B is equal to null vector. But the converse need not be true. But the converse need not be true. Justify your answer with an example. Justify your answer with an example. Here they have given you that if either vector A is equal to 0 vector or if vector B is equal to 0 vector, definitely A dot B will be 0 vector. But converse is not true, they are saying. Converse in the sense here, if A dot B is equal to 0, means if A dot B is equal to 0, then there is no rule like either vector A is equal to 0 or vector B is equal to 0. That one you prove with an example. That is the question here. Okay. Let us take the example here. Let vector A is equal to I plus j plus k, and vector B is equal to, I will take here I plus j minus 2k I will take. Let us check its A dot B. A dot B is equal to I plus j plus k, which is in dot product with I plus j minus 2k. What happens to the dot product of these two? 1 into 1 dot product of two vectors. It is just the corresponding components multiplication and taking the sum of all those. J component 1 and 1 plus 1. Here plus 1 is minus 2. So this is minus 2. 2 minus 2 is equal to 0. You see here A and B are two vectors. Their dot product is 0 vector. Their dot product is 0. But what about the vectors? Vectors are not null vectors. So this one we have proved. Here you may ask me the question like, how did you take the examples of vector A and vector B? Just manual calculation here. See, 1 into 1 1, here also 1 into 1 1 plus 1 2, and here if it is minus 2, if you take like that it will be fine. Or else let me take another one example here. Another example I will give you. Another example, very simple it is. See, vector A is equal to, you take anything, 2i plus 3j plus 4k you take. 2i plus 3j plus 4k, like that I am taking. Next, vector B is equal to, let me take here, this is 3i plus 2j I will take, 3i plus 2j. How much this will be? See, 2 into 3 6, here also 2 into 3 6, this will be 6 plus 6 12. That part should get subtract, that part should become 0. 12 here, no? Here already 4 is there. 4 into minus 3 will be 12, that becomes 0. So here you put minus 3k. Now you check the dot product of these two. 2 into 3 6 plus 3 into 2 6, 6 plus 6. Here 4 into minus 3 means minus 12. 12 minus 12, that becomes 0. Their dot product is 0, but those two are not null vectors. Okay, that is the question. In the same way, you can give many examples, all are correct only. Yes. What we will write here? Let me erase this another one example. Here simply we will write it like here A dot B is equal to 0, but vector A is not equal to null vector and vector B is also not equal to null vector. You can write it like this. Next, let us take the question number 15. Question number 15 is, if the vertices A, B, C of a triangle A, B, C of a triangle ABC or if a triangle ABC are 1, 2, 3, minus 1, 0, 0, 0, 1, 2 respectively, then find angle ABC. Okay. See here, we will use dot product of two vectors concept here. We want angle ABC, means suppose I have a triangle like this with vertices A, B and C. We want angle ABC, means this angle I want. This angle is equal to question mark. This angle is formed between what are the two sides? This angle is formed between the sides BA and BC. So what you do here? These are the points given to us. A points, B points, C points, means position vectors of these 3 points are given to us, so that we can write OA, OB and OC. Using those position vectors, we will find out vectors representing these two sides BA and BC. Those will be the two vectors. Let us take those two vectors as vector A and vector B. Then use the formula dot product of two vectors. We will get theta in that. Very easy. Let me solve this. Okay. Whatever the points are given, using those points, let us write the position vectors. Here, vector OA is equal to 1, 2, 3 are the scalar components over there. It will be 1i plus 2j plus 3k. Then position vector of the point B is OB. What is that? Minus 1i plus 0j plus 0k. Even if you know, we no need to write this. Next, vector OC, I component is 0. Directly we can write j component and k component, no problem. But let me write that. OI plus 1j plus 2k. This is what? This is vector OC. What are the two vectors I want here? I want BA and BC. Let me find out BA. BA is equal to, this is a vector joining 2 points. BA is a vector joining 2 points where A is the second point, B is the first point. Vector joining 2 points is like a position vector of the second point minus position vector of the first point. OA minus OB it is. What is OA? OA is I plus 2j plus 3k minus of OB is minus I plus 0j plus 0k. Now it is minus minus becomes plus, I plus I, 2i, then remaining part as 0. This will be 2j 3k. What is this? This is vector BA is equal to. Next, what about the vector BC? BC is also a vector joining 2 points B and C. B is the initial point, C is the terminal point. BC will be written as OC minus OB. What is OC? OC is 0 into I plus j plus 2k minus of OB is minus I plus 0j plus 0k. This will be 0 minus into minus plus, this is I cap plus j cap plus 2k cap, here it is 0. We got vector BC. Next, let me use the formula, that is dot product of two vectors between BA and BC. Using dot product of two vectors formula, BA dot BC is equal to BA dot BC is equal to, it is like A dot B. A dot B is equal to what we wrote? Magnitude of factor A into magnitude of factor B into cos theta. In the same way, BA dot BC is equal to, we will write magnitude of factor BA into magnitude of factor BC into cos theta. Here BA dot BC we want, magnitude of factor BA we want, magnitude of factor BC we want. Let us write all those. BA is, I will write it here only, 2i plus 2j plus 3k, which is in dot product with BC is I plus j plus 2k, which is equal to, what is magnitude of factor BA? Magnitude of factor BA is square root of 2 square plus 2 square plus 3 square, and then magnitude of factor BC is again square root of 1 square plus 1 square plus 2 square into that cos theta, you write as it is. Now dot product of two vectors is nothing but a corresponding components multiplication. 2 into 1 2 plus 2 into 1 2 plus 3 into 2 6, which is equal to, now here it is square root of 4 plus 4 plus 9 into square root of 1 plus 1 plus 4 into cos theta. This is 4 plus 6 10, 10 is equal to square root of 4 plus 4 8, 8 plus 9 17 into here square root of 6, this is cos theta. Now here I have 10 divided by square root of 17 into square root of 6 is equal to cos theta. We can simplify this. 10 divided by root A into root B is root AB, that is square root of 6 sevens are 42, 4 carry, and 6 sevens are, this is 102. 102 is equal to cos theta. You can leave it here. If you want to simplify further, there is no perfect square which is multiplying with 102, hence you can leave it here. Therefore theta is equal to cos inverse of 10 by square root of 102 is the answer. Yes, it is correct. Okay. Now we will take the next question, that is question number 16. Question number 16 is, show that the points, question number 16, show that the points A of 1, 2, 7, B of 2, 6, 3, and C of 3, 10, minus 1 are collinear. Okay. Here I will explain you what is collinear. Collinear in the sense points are lying on a single straight line. See, we need to show these 3 points A, B and C are lying on a single straight line. Suppose these points are not lying on a single line, what happens here? See, let us take A is lying here. Then if you join A, B and C, if you join A, B and C like this, you see, it forms a triangle. According to the triangle inequality, sum of two sides will be always greater than the third side length. It will not be equal to third side. Here, to prove A, B, C are collinear, what we do? We will find out AB length, we will find out BC length and we will find out AC length also. If you take sum of smaller two lengths, that should be equal to one bigger length, that is third length. If that condition is satisfied, all the points will be lying on a single straight line. Okay. Now, let us find out all three sides first, means all three lengths. Here, these are the points given to us. Points given in the sense, position vectors are given to us. OA, OB and OC are given to us. We need to find out AB vector. What is AB vector? AB vector is a vector joining 2 points A and B. So, we will find out AB vector. Using the AB vector, we will find out its magnitude. Its magnitude is nothing but its length. In the same, we will find out BC and we will find out AC also. Okay. Now, let me write what is given to us first. Given that A has the coordinates 1, 2, 7. That means its position vector will be vector OA is equal to 1i plus 2j plus 7k, and B has the coordinates 2, 6, 3. Then we will write vector OB here. Vector OB is equal to 2i plus 6j plus 3k. Then what about the vector OC? OC is 3i plus 10j minus 1k. Okay, fine. OA, OB and OC position vectors we wrote. We will write vector OB, vector AB now. Vector AB is a vector joining 2 points A and B, where B is terminal point, A is initial point. So, vector AB is equal to vector OB minus vector OA. Vector OB we know, that is 2i plus 6j plus 3k minus of vector OA is I plus 2j plus 7k. Now, let us subtract these two. 2i corresponding components I is there, 2i minus I is I, 6 minus 2 is 4j, 3 minus 7 is minus 4k. What is this? This is vector AB is equal to, we want its length, let us find out the magnitude of this. Magnitude of vector AB is equal to, this is square root of, here I component is 1 square plus 4 square plus minus 4 square. This is square root of 1 plus 16 plus 16, square root of 16 plus 16 32, 32 plus 1 is 33. 33 is not a multiple of any perfect squares, let it be here. This is what magnitude of vector AB is equal to, that is length of vector AB. Next, let us find vector BC. BC is a vector joining 2 points B and C. This will be OC minus OB. OC we know, that is 3i plus 10j minus 1k minus of vector OB is 2i plus 6j plus 3k. Now, subtracting the corresponding components, 3i minus 2i is minus I, 10j minus 6j is 4j minus k, this is minus 3k, means this is minus 4k. Vector BC is equal to, let us find out length of vector BC. That will be magnitude of vector BC. Magnitude of vector BC is square root of 1 square plus 4 square plus minus 4 square. We have this square root of 1 plus 16 plus 16, that is square root of 33, again What is this? This is length of vector BC is equal to. Next, let us find out third one, that is AC. You can take AC or CA, no problem. Anyhow, you want the length here. Okay. AC is a vector joining 2 points A and C. It will be OC minus OA. What is OC? OC is 3I plus 10J minus K, minus of OA is 1I plus 2J plus 7K. Yes, subtract it. 3 minus 1 is 2I. 10 minus 2 is plus 8J minus K. Here it is minus 7K. Will be minus 8K. What is this? This is vector AC is equal to. Now, length of vector AC is magnitude of vector AC. Magnitude of vector AC is a square root of 2 square plus 8 square plus minus 8 square. This is square root of 4 plus 8 square 64 minus 8 square 64. 64 plus 64 128. 128 plus 4 132. Check. 132 is it multiple of any perfect squares? We can divide it by 4 here. Yes, as you can divide it by 4, we will write here magnitude of vector AC is equal to square root of 4 into 4 3s, 1 will be there, 12, again 4 3s. This is 2 into square root of 33. What is this? This is vector AC is equal to. You see, length of AB and length of BC sum is equal to length of AC. So, these 3 points are collinear. Let us write it like vector AB means length of vector AB plus length of vector BC is equal to root 33 plus root 33. This is equal to 2 times root 33 is same as length of AC. AB plus BC is equal to vector AC. Therefore, the points A, B and C are collinear. This is about problem number 16 in the exercise 10.3. Now, we will take the next question, that is question number 17. Question number 17 is, show that the vectors 2i minus j plus k, 2i minus j plus k, comma I minus 3j minus 5k and 3i minus 4j minus 4k form the vertices of a right angled triangle. Form the vertices of a right angled triangle. Show that the vectors form the vertices of a right angled triangle. Vertices of a right angled triangle in the sense these are the position vectors. We need to find out vectors representing the sides of triangle, then we need to show those are forming right angled triangle. So, let me take let A, B and C are the vertices of right angled triangle. Here what will be OA? Then OA is position vector of the first point, that is given as 2i minus j plus k. And then what is OB? OB is position vector of the second point, I minus 3j minus 5k. OC will be the position vector of the third point, that is 3i minus 4j minus 4k. Let us find out vectors representing sides of right angled triangle, that will be AB, BC and CA. AB is what? AB is OB minus OA. OB is I minus 3j minus 5k minus of 2i minus j plus k. Subtract the corresponding components. I minus 2i minus I minus 3j, this is plus j minus 2j minus 5k minus k means minus 6k. What is this? This is vector AB is equal to. How will you show a right angled triangle? Using Pythagoras theorem, that is sum of square of two sides is equal to square of a third side, means length of on those sides. Here AB is there, we want its length, let us take the magnitude. Magnitude of vector AB is equal to square root of minus 1 square plus minus 2 square plus minus 6 square. We have here it is square root of 1 plus 4 plus 36. 1 plus 4 plus 36 is square root of 41. This is magnitude of the side AB. Here actually we want a square of sides. So let us square on both sides. Magnitude of vector AB square is equal to 41. Let it be as it is. Now we will find out second side, that is BC. BC is OC minus OB. What is OC? OC is 3i minus 4j minus 4k minus of OB is I minus 3j minus 5k. Subtracting the corresponding components, 3i minus I, 2i minus 4j, it is minus minus plus means minus j, it will be minus 4k minus minus plus 5k, it will be plus k. What is this? This is a vector representing the side BC. Let me find out its length. Length is magnitude of the vector. Magnitude of vector BC is equal to square root of 2 square plus minus 1 square plus 1 square. We have it as square root of 6. We want square of the side. So magnitude of vector BC square is equal to 6 it is. Okay. Now let me find out the third side also, that is vector AC. Vector AC you can take or vector CA you can take, no problem, because we will be taking the length, Vector AC is equal to vector OC minus vector OA. Let us write vector OC. Vector OC is 3i minus 4j minus 4k minus of OA is what? OA is 2i minus j plus k. Subtracting the corresponding components, 3i minus 2i is plus I minus 4j minus minus plus j means minus 3j minus 4k and it is minus k means minus 5k. What is this? This is vector AC is equal to. Now magnitude of vector just it is the vector AC, we should not read it as modulus. Magnitude of vector AC is equal to, we have it is square root of 1 square plus minus 3 square plus minus 5 square. Magnitude of vector AC is equal to square root of 1 plus 9 plus 25. 1 plus 9, 10 plus 25. This is square root of 35. What is this? This is magnitude of vector AC is equal to. Now squaring on both sides, magnitude of vector AC square is equal to 35. You see, if I take sum of squares of two sides. If that is equal to square of the third side, that is Pythagoras theorem. Pythagoras theorem, is it satisfying here or not? We will check. Let us take the sum of squares of side BC and side AC. What happens? This is 6 plus 35 is equal to 41, is same as square of the side AB. With this, what we can say? We can say that the vertices are forming a right angled triangle with right angle at the vertex C. See, side AB square is there, in the sense right angle will be at the vertex C. Okay. Therefore, the points, the given points are forming a right angled triangle. This is about problem number 17 in the exercise 10.3. Now, we will take the last problem, that is problem number 18. If vector A is a non-zero vector, question number 18, if vector A is a non-zero vector, if vector A is a non-zero vector of magnitude A and lambda non-zero scalar and lambda non-zero scalar, then lambda into vector A is a unit vector, if there are four options given to us. First one, if lambda is equal to 1, B lambda is equal to -1, C A is equal to modulus of lambda, and D is equal to A divided by A is equal to 1 by modulus of lambda. Very simple question it is. If A is a non-zero vector of magnitude A units, its magnitude is A unit, means its length is A units. Lambda is a non-zero scalar, means lambda is any real number. Then they are saying that lambda into vector A is a unit vector. What do you mean by unit vector? Unit vector means its magnitude, its length is 1 unit. Here they are saying lambda into vector A is equal to 1 unit. Now, is A is a unit vector if what is that condition satisfies here? Very simple it is. You see, you can write it like a modulus of, because it is magnitude, magnitude in the sense positive. Here you should write a modulus, that's why. Modulus of lambda into magnitude of vector A is equal to 1. They have given you magnitude is A, its magnitude is A, in the sense modulus of lambda into A is equal to 1. Now, A is equal to 1 divided by modulus of lambda. This is correct. So, option D is correct here. Thank you. With this, exercise 10.3 completes.